Hi, today we're going to take a look at section 10.3, which is called Operations on Radical Expressions. This section actually has several different mini lessons in it, and we're going to break it apart into 3 different days. Day number 1 here, we're going to talk about the operations of addition and subtraction on radicals. And as it says here, here's kind of the gist of it. In order to add and subtract radicals, the radical part has to be the same. Okay? In other words, they have to be like terms, essentially. Okay? And that's all that really is saying. It's no different than if I did 4x plus 3x, I get 7x. You guys know that in order to be able to add those, they have to be like terms. The variables both have to be x's, they have to be the same powers. Again, you can only add x's with x's and y's with y's and so on. Well, the same thing is true with this. Okay? Instead of 4x plus 3x, what if I had 4 square roots of 2 plus 3 square roots of 2? Well, yeah, the radical part's the same. We're going to add square roots of 2's to get 7 square roots of 2's. Okay? It's just a counting game is all that it really is. Okay? All right, so let's take a look at a couple examples here. Up here on the left. Look at, if you notice all of these, they're all square roots of 2's. They're all like terms, so we can combine them. This is 3 minus 5 is negative 2, plus 4 is positive 2 square roots of 2. Okay? And when we add and subtract these, notice again, the radical part itself does not change. We're just counting how many square roots of 2's that we have. When I look at the second one, they're all square roots of 11. Again, they're all like terms, so let's combine them. 6 plus 2 is 8, and 8 minus 9 is negative 1 square roots of 11. Okay? Letter C here. Okay, now there's 4 terms there. Not all of them are the same. But if you look closely, there's some that are the same. I can add those together. They're both square roots of 5, and negative 14 plus 6 is negative 8 square roots of 5. And then also these 2 guys on the outside, they're both square roots of 3's. And I can combine them. 15 minus 11 is 4 square roots of 3's. Okay? Can we combine square roots of 5's with square roots of 3's? Nope. Okay, that's as far as we can go. It's no different than saying negative 8x plus 4y. You can't combine x's and y's. We just leave it as 2 terms in our answer. Okay? And this guy over here, here's a couple like terms. Square roots of 3's with square roots of 3's. 4 minus 6 is negative 2 square roots of 3's. And then the square roots of 7's are like terms. 3 square roots of 7 plus another 3 turns into 6 square roots of 7. Okay? And again, they're different, can be combined, and we're done. One question I get a lot is, does it matter which one of these you write first? No, it does not. Okay, they can be in any order, just as long as you make sure that they have the correct sign on them. Okay? So once again, the key word here with adding and subtracting radicals is that they have to be like terms. The radical parts have to be the same in order to combine them. Okay, well, what if the radical parts are not the same? Okay, so for example, what if I had the square root of 27 plus the square root of 12? They don't look the same. They look totally different. So now what? Can you combine them? Well, let's see here. Do you remember something from the previous lesson that we can maybe do with the square root of 27? Could we possibly separate it or simplify it and use our factor sheet and find a couple factors? And if you look on your factor sheet, the 2 that are in black are 9 and 3. And the square root of 9 is 3. So 3 square roots of 3 is what that one turns into. Could I do the same thing with this one? What if I did 4 and 3? The square root of 4 is 2. That turns into 2 square roots of 3. And look at that. Voila, there's a magic trick. They started out looking totally different. But did they actually simplify into 2 terms that now have the same radical? Yeah. They both now have square roots of 3, so let's add them. 3 plus 2 gives me 5 square roots of 3's. Okay, and that's the gist of it. What if they're not the same? Well, oftentimes we can make factor trees and factor them into two terms that are the same, and then we can combine them. Okay? Let me do one more example here. Okay? What if I had 3 square roots of 8 plus 5 square roots of 18? Okay? Now square roots of 8 and square roots of 18 don't look anything alike. But what if I simplified the square root of 8 into 4 and 2? And the square root of 4 is a 2. Notice again how I cross off the perfect square. Now the difference on this one is, notice, there's a multiplier. There's a number in front. Don't forget to multiply those together. 2 times 3, that's 6. Square roots of 2 is what that first one turns into. 18 can also be broken apart into 9 times 2. 9 turns into a 3. And 3 times 5 is 15 square roots of 2. And here again, it didn't look like they were the same to start with, but they both actually turned into square roots of 2's. And 6 plus 15 is 21 square roots of 2's. Okay? Yeah. So again, if they're not the same, break them apart, show your work. I think we can all agree that there's a little bit of work to show again. I need to see those factor trees. I need to see how they turn into the two radicals that are the same before you add them together. Okay, just so we're all clear on that. Okay, here's two problems I'd like you to try by yourself. Okay, push pause on the video here, try them, and then unpause and keep going. We'll keep going, we'll do them together. Okay, ready, set, go. You give it a whirl. Go. Okay, welcome back. Let's give it a try here. These two radicals are different. Let's try and simplify them. 9 times 6. Again, I'm going to make reference to your factor sheet, the black ones. The square root of 9 is 3. 3 times 4 is 12 square roots of 6. Okay. This one, the two black ones on your factor sheet are 6 and 4. 4 turns into 2, and 2 times 2 is 4 square roots of 6. Once again, they didn't start out looking the same, but they turn into two that are the same. 12 plus 4 is 16 square roots of 6. Okay, good. And how about this guy? 12, I can do 4 and 3. Square root of 4 is 2, and 2 times 4 is 8 square roots of 3. 48, now 48 has a lot of factors, but it only has one pair that are in black. And if you look closely, it's 16 times 3. 16, the square root of 16 is 4. 4 times 6 is 24 square roots of 3. Okay, and now again, now they are the same, so let's subtract them. 8 minus 16 is going to be negative, 8 minus 24 is negative 16 square roots of 3. Okay? Alright, so hopefully those didn't go too bad, but that's basically what you're doing on your homework assignment today. A little bit of work, but not too terribly bad, I hope. Okay? One more here. Okay, I'd like to try this one on the left. Okay, let's try this guy on the left. Some big numbers. Same type of thing. Okay, is it okay to add or subtract 3 things? Yep, you might see 3 terms, you might see 4 terms. But let's just simplify each one as much as we can. So they all start out looking different, but if I did 9 and 5, 9 turns into 3, and 3 times 3 is 9. Square roots of 5 is what that first one looks like. Okay? The square root of 20, 4 and 5, and the square root of 4 is 2. This one doesn't have a multiplier, so it's just 2 square roots of 5. Okay, and they're looking like terms so far, aren't they? Okay? Now 245. Oh boy. Bad news, that one's not on your factor sheet. But from a previous lesson, when we just simplified radicals, if it was too big to be in our factor sheet, we tried simplifying by dividing one of these numbers into it. And then I think the highest we had to go was 7 squared. Okay? But if you try your calculator, now 1, it really doesn't help us. But if I try taking 245, and maybe I'm going to try dividing it by 4. 245 divided by 4. Does that come out to be a nice number? No. So I'm going to try 245 divided by 9. Doesn't work either. Okay? Well, if 4 didn't work, 16 isn't going to work. Let's try 25. 2 divided by 25. That doesn't work. It's not a nice number. Okay? 245 divided by 36. Not good either. Oh, let's try 245 divided by 49. That does work. Okay? So we just kind of keep going down our list until we find one that works. And 49 does go into that. It's 49 times 5. And the square root of 49 is 7. There is no multipliers, just minus 7 square roots of 5. Okay? So you're going to see a couple problems that have a number that's too big on your factor sheet. Just try dividing one of these into it. Turns out these all end up being square roots of 5 if I combine them. 9 plus 2 is 11, and 11 minus 7 is 4 square roots of 5. Okay? In a nutshell, that's what we're doing today. Okay? Make sure you show your work, show me your factor trees, and then combine your like terms. All right, short and sweet. Thanks for tuning in.